Students of Standard 9, how are you? Hope you are fine. Today I will show you some mathematical problem of chapter 4. You know I will take your test on Thursday. That's why today I will take such class for you. Dear students, look at the question. A motor of 15 kilowatt can lift 2 quintal water in 1 minute at a height of 300 meter. What is the effective power of it? That means the effective power of the motor. B number, what will be the change in spent energy by the motor if the efficiency is increased by 5%? So dear students, if you have copy with you, you will pick it up in your copy. Pick up the question. So here, solution of A number, what is the effective power of the motor? Here 15 kilowatt, that is the input power of the motor, and we have to find out the effective power, that means our output. So P equal to power equal to work by time. Here work equal to what? mgh divided by time. So work equal to mgh. Here what things are given in the math? Here the input power is given, but here we don't need input power. We have to find output power. 2 quintal water, that means mass is given 2 quintal. You know 2 quintal equal to 200 kg, because 1 quintal equal to 100 kg. So 2 quintal equal to 200 kg. And height is 300 meter and time is 60 seconds. And another one, the value of G, that is 9.8, we all know it and we require that. So 200 into 9.8 into 300 divided by 60 seconds, it comes 9,800 watt. So the effective power will be 9,800 watt. Let's do B number. So in B number, what you have to find out? What will be the change in spent energy spent by the motor if the efficiency is increased by 5%. So look everybody, in the stem it is not given what is the efficiency in the first case. Okay, so I have to find out the efficiency at first. And efficiency, if efficiency is increased by 5%, then what will be understood from it? That means the motor can do perform the work in less time, and also the effective power of the motor will be more. If the efficiency of any engine is more, that means the engine can perform the work in less time. So we have to find out the time also. In the first case, the time is given, that is 60 seconds. 1 minute, that is 60 seconds. So here what is given? Input power is given 15 kilowatt. 15 kilowatt means 50,000 watt. So energy spent equal to what? In this time 60 second, in the time of 60 second, energy spent equal to P input into time. So if we multiply these two, we will get 9 lakh joule. And P output, that is already found out in A number, that is 9,800 watt. So easily we can find out the efficiency in the first case of the motor. P output by P input into 100%. That is the formula of finding out efficiency of any engine or motor. So here P output 9800 and P input, look, this of 15,000. So it comes 65.33%. Okay, the efficiency becomes this. Now what is told? If the efficiency is increased by 5%, so in that case the efficiency, I write here eta prime. Here it is eta and here it is eta prime. Eta prime equal to just 5%, we will add there and we get 70.33%. That can be written as 0.703. Okay, because you know how it can be converted into that, I think you know. So now we will find out what? We will find out the power output in this efficiency. Okay, so efficiency equal to P output by P input. Okay, so P output equal to P input into eta prime. By multiplying these two, we will get what? 10,549 watt. P output becomes that. So now I have told you already, If the efficiency is increased, then the time will be less. So let's find out the time. So if the required time is t prime, I have told you if the efficiency is increased, then the time period will be changed. So if the required time is t prime in that efficiency, then p prime equal to mgh by t prime. So t prime equal to mgh by p prime. Okay. Then you know m is 200 kg, 9.8 h equal to 300, and p output equal to effective power equal to this. So I got time will be 55.74 second. That means you can see the time required is less than that of the previous case when the efficiency is increased by 5%. So the spent energy, easily you can find out, you know, energy equal to power into time, input power into this time. Okay, in the first case we have find out the energy in 60 seconds, but now we will find out the spent energy in 55.74 seconds. So input energy, input power, you got it, and then the time is that by multiplying these two we get what, 836100 joule. Now we have to find out the change of spent energy. So del E equal to E1 minus E2. Previously we got 9 lakh joule, and now 8,36,100 joule. Okay, so by subtracting this, I got the change in the energy spent equal to what, 63,900 joule. Dear students, I think one number question you have understood. Now I will show you two number. A car of 4,000 kg starts from rest, acquired a velocity 10 meter per second after 5 seconds. And another car of 10,000 kg mass acquired the same velocity in the same time. Both cars run with 500 kilojoule. That means that is the energy given to the cars to run. A number, calculate the effective power of the first car, and B number, compare the efficiencies of the two cars. So you know effective power equal to what, work by time, work equal to force into displacement by time, but force can be written as what, force F equal to ma according to Newton's second law, ma into S by T. But here two quantities we don't have, that is acceleration and displacement. But look, the car starts from rest, that means its initial velocity is 0 and acquired a velocity of 10 meter per second after 5 seconds. That means after 5 seconds of starting, its final velocity becomes 10 meter per second. So acceleration easily we can find out, acceleration equal to v minus u by t. So here if we put the value of v, u and t, we get acceleration equal to 2 meter per second square. I think you understood. Now also we have to find out this quantity s, that means displacement. So for finding out displacement, we can use that formula, s equal to ut plus half of at square. You know all this formula. Here ut becomes 0 because initial velocity is 0. The car starts from rest. Okay, so s equal to half at square because ut to 0, half at square. If we put the value of acceleration and time, we get s becomes 25 meter. Now if I put the value of mass, acceleration, that is 2 meter per second square, mass is what, mass is first car, so first car mass is 4,000 kg and s equal to 25 divided by time equal to what, 5 seconds. Okay, so the power becomes 80,000 watt. Do you understand? Now I will show you B number. In B number, compare the efficiencies of the two cars. Okay, দুটা কারেরই কি দেওয়া আছে, mass is given, mass of the both cars is given, and also we have found out that acceleration of both car is same, acceleration was what? 2 meter per second square, and displacement equal to 25 meter per second, 25 meter. Now we will find out the efficiency of the two cars. Now input energy of both cars is given, that is 500 kilojoule. So 500 kilojoule can be written in that way, because you know 1 kilojoule equal to 1000 joule. So by multiplying 1000 we got that. Now effective energy of the first car, okay, equal to mass effective energy. That means we have to calculate the work done. So mass calculate work done equal to force into displacement. That means MAS. Here M is 4000, A is 2 meter per second square, S equal to 25. We got what? 2 lakh joule. Okay, that is the effective power. So find out now we will find out the efficiency of the fast car. Efficiency equal to, we know as usual, P output by P input into 100%. So by putting the P input it is already known. Here I have written. So by putting all the value, we get the efficiency of the first car is 40%. So let's find out the efficiency of the second car and then compare both. Here students, input energy of both the cars 500 kilojoule. I have already told you. Now we will find out the effective energy of the second car, and also we will find out the efficiency. For finding out efficiency, we need the effective energy of the second car, because we know, mistakenly I have written here P, but it will be E, everybody. Yeah. So efficiency equal to effective energy by input energy into 100%. So input energy we have already 5 lakh joule, and also we got effective energy 5 lakh joule. So here I can find out effective energy by multiplying mass into acceleration to displacement. I think you understand this calculation. You can ask me why the acceleration is same of both cars, because both the cars start from the rest position and they acquire the same velocity after 5 seconds. So obviously their acceleration should be equal and their displacement also equal. So efficiency is 100% of the second car. Now here in the question you have to told compare the efficiencies of the both cars. So you can compare in many ways. You can also find out ratio. You can subtract the efficiency. I think ratio is better. So here I have find out the ratio of both the efficiency of both the cars into eta 2 by eta 1 equal to 100 by 40, that is equal to 2.5. Okay, and also you can tell here the efficiency of the second car to first car is what? 5:2. In this way also you can explain. Today, up to this, everybody, I think you understood the those maths that I have done in the class, and also I will give another math to do in the messenger. You will solve that math and submit it to me. Goodbye, everybody.